All right, and you're live.
Good afternoon. We'd like to welcome those of you who are Gulf Specimen Marine Lab fans to our Friday live feed. And in case I forget to mention it at the end, we'd love for you to tell us in the comments below what time you would like this live feed, because we've kind of switched times a couple times and we want the most people to be able to watch it. So let us know. And my name is Leslie Breland and the camera operator is Allison Chin. We are happy to have you here. And our subject for today is symbiosis, which means essentially living together. And there are lots of things both on land and in the ocean that have, quote, symbiotic relationships, which means that they are living together with another organism, and that relationship is often very, very close, sometimes almost necessary, and sometimes it's as though they're just kind of acquaintances, getting together for a while, maybe for the benefit of one, and then of course we have things in which one organism is benefited and the other is harmed. We call those relationships parasitic relationships. Commensal relationships, when we have one organism that's benefited and the other organism really doesn't care, kind of like sharks and remoras. The remora is definitely benefited. It's a free ride, gets leftovers from the sharks feeding, and the shark, I don't think it really cares. It may add a little drag on occasion, but it doesn't seem to be affected much by the presence of the remora or shark sucker. And then there are mutual relationships where both of them are benefited. And I want to start with some of those mutual relationships, because here at the aquarium we try not to keep the parasitic things, because that's going to infect the other animals. And so I don't have many examples of that to show you, and we'll probably do it as a slide, but I do want to show you these two organisms. These little guys are trying to hide in here. But this lovely coral, that little crab is just determined to be there, and that's okay. He wants a good hiding spot. And these little jellyfish, the upside down jellyfish. And the reason I want to show you that is because one of the most important symbiotic relationships in the ocean is the relationship between these animals and a tiny little single-celled algae that's often referred to as zooxanthellae. And those algae are in a group called the dinoflagellates. And besides having green chlorophyll, they also have kind of reddish pigments that give the algae its color. And in these two organisms, those algae, the symbiotic zooxanthellae, live inside the cells of both the little upside down jellyfish and the coral. And the wonderful thing about that is, as they photosynthesize, they leak food to the coral and to the jellyfish, so that a portion of their necessary food supply is provided to them by their little algae that are living inside of them. And for the algae, they get protection. They're inside a stinging organism, so not much is likely to come by and eat them. And in addition to that, they're going to get carbon dioxide that the coral and the jellyfish give off, and they need that for photosynthesis. And they're going to give off oxygen, and the jellyfish and the coral need the oxygen to survive. So this is a very, very intimate relationship. The organism is living right inside the cells of the other organism. When corals and jellyfish release eggs, oftentimes those eggs not in the nucleus of the egg, but in the outer parts of the egg, will have the zooxanthellae. And the zooxanthellae give the color to this jellyfish. You know, a lot of jellyfish are transparent and clear, and this one has that beautiful brownish, reddish brown color that is given to it by the zooxanthellae. There's several different kinds of zooxanthellae. Each of them have different kinds of pigments. This coral also has zooxanthellae, and it's sprinkled throughout the tissue of the coral, not just in the polyps, but also in the tissue that connects each polyp to one another. So a very close, intimate relationship. Okay, I want to move over to this organism right here. This little hermit crab is sporting two lovely, huge cloak anemones. In our area, they're sometimes called three-color anemones. This little, what looks like a little mound or mountain of brown and cream, and over here the same thing. And these get a free ride from the hermit crab so that it gets better current flow and more likelihood that it will come into contact with food. This one, I don't know if Allison can show you, but this one, today was feeding day at the aquarium, and this one has munched on a piece of fish and is working on the backbone of that fish, and will discard the backbone eventually after it's digested off all of the good part. Now, the reason that the hermit crab is happy to carry around his little friends is because sea anemones are related to jellyfish, and so they have stinging cells. And that means that that gives him some protection from predators like octopus, for instance, which love to eat hermit crabs, but they don't want to snuggle their little suckers right up against a sea anemone or a hydroid. And so that helps the hermit crab out. And you'll notice that the hermit crab actually signals the anemone when it comes in contact with one by stroking the anemone on the side, and that will trigger the anemone to release from whatever bottom it's on, and he can pick the anemone up and he'll position it on his shell, and he tries to position it right here close to the front so that it's going to drape over the front of the shell where he's going to get the best protection. I had a picture here. Yep. I have a picture of this same hermit crab with a bunch of anemones, and then another hermit crab with anemones, and the anemones are open, and you can see the little tentacles, and each of those tentacles is going to be filled with stinging cells. So it really is going to give the hermit crab some protection, and it's going to make it easier for the sea anemone to feed. Now, I have one more mutual relationship that I want to talk about that you are all familiar with, and that's the relationship between Nemo, okay, the clownfish, okay, and its anemone. Now, in the wild, clownfish are usually found in a great big anemone that has a huge upper surface. It's called a carpet anemone because it's got lots and lots and lots of little tentacles that emerge from this big oral disc. And here you can see it's one of these big carpet anemones. Now, the relationship between the clownfish and these big anemones is that the clownfish gets protection by hiding in the stinging tentacles. There's very few things that are going to chase it right down in there because they're going to get stung. Now, normally, any fish who touches those tentacles would get stung. But those of you who watch Nemo know that Nemo has to bathe in the tentacles, and they do that initially. They start along the edge and they come up against one or two of the tentacles, and then they come up against a couple more, and what they do is incorporate the mucus of the anemone into their own mucus, so that after a while, if it bathes continually and gets more and more of the mucus from the anemone into its own mucus, when it gets up against the anemone will not recognize it as something else. It will not go, oh, it's fish for dinner. Okay, if you were to take that little clownfish and take all the mucus and take it off of there, okay, and then put him back in the anemone, he would get stung and the anemone would eat him. So he has to kind of cultivate this relationship over time, and he has to make sure that he's constantly vigilant about getting the mucus from the sea anemone into his own mucus. Okay, now we're looking at an anemone that is found in South Florida, the tropical or plumed anemone. And this little anemone doesn't house clownfish, but it does usually have a lot of it has cleaning shrimp that set up stations in the anemone, and their coloration will mimic the coloration on the anemone, but they'll also have these big, long, white antennae. The antenna will be 3, 4, 5 times as long as the shrimp, and they wave those antennae back and forth, and that signals fish in the surrounding community that this is a cleaning station, and fish will come over and they'll actually line up next to that anemone and wait for the shrimp to come, and they'll open their mouth. The little shrimp will clean in between their teeth. They'll eat any parasites that are on the surface of the fish, and sometimes on a reef there are several things that can do cleaning. There are several different cleaning shrimps. There are several cleaning wrasse. It's a little fish. There are some juvenile fish that will do cleaning. But anyway, when predatory fish come to the reef or come to the cleaning station, they oftentimes have to signal that they're not there for dinner. Before the little shrimp will come out and clean between his teeth, that predator may have to signal in some way. And I'm going to grab this picture over here. Here you see a number of cleaning fish that are working right in the mouths and on the surface of these fish, and the fish are allowing them to do that without getting in trouble. But over here, here's the picture I want you to see. Hammerheads come, but this little fish is standing on its head, okay, with its head down towards the bottom and its tail up. And that is a classic signal to cleaning fish, that he is there to be cleaned. He is not there for dinner. There are also a lot of fish like Barracuda, which are normally real silvery, will turn like black and white banded. There are groupers that will have a banded coloration when they come to the cleaning station, so that the cleaning organism knows that that fish is there to be cleaned. He's not there as a predator. Okay, all of those relationships are mutual relationships. Everybody's getting something out of the relationship. The little cleaning shrimp is getting dinner. The fish are getting cleaned of dead skin, stuff between their teeth, parasites. So it's beneficial to both of them. The clownfish is getting protection. The sea anemone gets extra food because other fish think, oh hey, he's doing okay, I can come right in too, and then they get stung. So both of them are being benefited. Now we want to talk about some relationships where one of the organisms is definitely benefited, but we don't know about the other organism, whether they're getting benefited or not. In fact, we think oftentimes not necessarily. Now, it may become more beneficial over time, but there's like a whole continuum out there. And one of the organisms that takes advantage of these little commensal relationships is this little worm. This tiny, I don't know if you can even see it.
Where is it?
It's right here.
Oh.
Can you see him? I'm hoping you guys at home can see him.
You stick my finger and make him move.
Maybe make
there
him swim.
You go.
There he goes. Now that you can see, he really is a worm. Okay? And that little worm lives right around the mouth of sea urchins. So that as sea urchins are feeding, and they may not get every little bit and scrap of algae, he can feed on that material without having to take his own life in his hands and go out there in the big wide world to find his own algae. Okay, and I want to show you, this is the sea urchin. Oh, he escaped.
Let's put him back on the sea urchin.
Yeah.
Oh. Oh.
Here, we may try this again. We'll try and put him, we took him off of there so you could see him, because sometimes he lives right in this little area right here around the mouth. And when he's in there, oh, I just poured him out. Bad teacher. Good. But anyway, you can see the teeth in the middle of the mouth of this little sea urchin. It has 5 little teeth, and that little worm sits right up inside there amongst the spines of the sea urchin.
Okay, there you go.
There, we're trying to send him home. There he goes. See, he just disappears in there. You can't even see him. That's why we took him out of there. He's so hard to see. Anyway, I'm going to turn this urchin back over, and he and his symbiont can, you know, get together again the way they were originally. Okay, now here's another worm I'm going to show you. And this little worm looks like pus on the bottom of this horseshoe crab. Right here in the middle of his mouth is one. Let me see if I can get him to open up a little bit if I put him underwater. Just a tad. There's some right here. There's one here. There's one here. I'm going to see if I can get some of them to come up on the side. And that way, maybe you can see them a little better. No, they're just not cooperating at all. But when you pick up a horseshoe crab and turn it over, oftentimes you'll see little spots, particularly on the joints of the legs, that look like it's got this soft, pussy stuff. And it's not that the horseshoe crab is injured. That's this little flatworm. The flatworm is called Delura, and he actually feeds on the material that grows on the horseshoe crab. He's not a parasite. He doesn't hurt the horseshoe crab. And he, of course, gets meals in a safe, protected area. And the horseshoe crab really doesn't care whether he's there or not. Or at least that's what we believe. Since none of us speak horseshoe crab, we don't know that entirely. Okay, now I want to talk about this little sea biscuit here. And I'm using him as an example because I don't have a good example of a sand dollar. But we have in our area, on our sand dollars, we get these tiny, tiny, tiny little crabs. And those crabs are found in these little grooves. And those grooves are there because it goes through the sand. It's got cilia in each of these grooves that picks up tiny little food particles and moves those food particles towards the mouth, which is right. it has a crab, it's going to sit right in one of these little grooves. And the food is coming on down. Okay, I'm going to show you a picture of a local sand dollar because, nope, that's all parasites. Here we are. Okay, but you can imagine how tiny this crab is. These are like 1/8 of an inch across. They're just tiny, tiny, tiny. And here's one of the little grooves, and here's one of the little grooves. And it just sits there, and there are usually 2 of them. When you find one, you'll usually, if you look closely, you're going to find a mate on that sand dollar. Okay, and they're just getting free food, and the sand dollar is not getting hurt. Okay, oh look, our little anemones out there. How fun.
Oh.
You can see his little orange coloring in the center there. They're called tricolor because they're kind of orange and brown, and they have some pink oftentimes on the end of those tentacles. Oop. we give the anemones a horrible time. But anyway, we want to talk about this organism and this organism and this organism. These little crabs are all members of the spider crab family, and members of the spider crab family have on the surface of their shells little hooks, and they attach things to those little hooks, at sponges, sea pork, bryozoan pieces, and they will trim those little pieces down and attach them to those little hooks, and they will grow over time to really camouflage that little crab. That one's got a little bryozoan.
How about this
got
one?
A sponge.
It's like a haircut.
Yep, they do. They trim those pieces and make them fit so that they really are very well camouflaged, and oftentimes you can't see them at all. Okay, now they're not the only ones that like to decorate themselves with sponges. Here we have what's called a sponge crab, and I know you can't see the crab because this is all sponge on the outside, but right here is the little sponge crab, and he hangs onto the sponge with his last pair of legs. Okay, and he gets lots of protection and camouflage. Look at, he's got like that pink nail polish. I love it. On the end of his little claws there. Okay, and he gets all this protection. If he sits still, you would swear a crab was even there. Now, sometimes they use sponges, which is a little bit different, but oftentimes the sponge crabs in our area use sea pork instead of a sponge. And that is what has happened here. You see that this crab is a little bit larger. Okay, and once again, he's hanging on to the sea pork with those last 2 legs. I'm going to try and make sure he stays nice and wet. But then when he's sitting still on the bottom, you think it's just a piece of sea pork. You have no idea that there's actually a crab underneath there.
I can see their last pair of legs when you kind of like lift them up.
Yeah, they're hard to see. They get almost embedded in that, whatever it is they're carrying around.
This one you can almost see. It's like a...
Yeah. But you can see that he's loose from that sponge, really. He's not attached to the sponge except where those back legs are hanging on to the sponge.
Okay.
Okay, now, that's commensalism. These are organisms that have a relationship with another organism, and they get benefited The other organism doesn't necessarily care. You know, that sponge could grow anywhere. It just got picked up and is being used by the sponge crab. But I am going to show you a couple of examples of parasites which we work really hard to keep out of our aquarium. One of which is what we call a fish louse. Okay, and fish lice are an isopod. They're like that big giant sea roach that you sometimes see, and they can attach, this one's attached to the head of this fish, right on the top of the head, but oftentimes they'll get under the gill cover where it makes it, and they actually suck the tissue, they suck the fluids from the fish, so like plasma, sometimes blood, but any nutrient-filled fluid that is going around through the fish. This is another type of common fish parasite. This one is actually a copepod, and copepods are usually little, I call them sea cows, because they eat algae all the time, little single-celled diatoms and dinoflagellates. They're tiny little animals, but they're the world's most abundant animal, the copepods actually. So there are lots of different kinds. This one is a parasitic kind, and it attaches to the gill tissue of the fish. That's what all this pinky red tissue is. And it sucks the fluids and the blood, again, from the fish. And these are egg sacs that are on the back of that copepod. So once those hatch out, the little larvae are going to be looking for other fish to parasitize.
They kind of sound like mosquitoes.
They are, and you know, one thing I want to mention about parasites is a good parasite doesn't kill the host. The whole idea behind being a good parasite is that you want the host to be able to support you. So oftentimes you find things that are parasitized, and even though they're being harmed, they may not be killed unless some other negative situation is there. Now, I want to talk about this. All of this white material on the bottom of this crab is the egg sac of a parasitic barnacle. And the barnacle, when it's in this little larval stage called a nauplius, it looks kind of like a shield with legs. Okay, it penetrates usually through one of the soft spots in the joints of the crab, and it goes to the crab's brain, and it literally takes over the hormonal system of the crab. And even if the crab is a male, it will metamorph and take on the characteristics of a female. So you know how the female has this big wide apron that it would use to protect its eggs? It does that, and then instead of a sponge of eggs, it gets this big egg-filled, barnacle egg-filled sac that will eventually rupture and release lots more of these little larvae to infect other crabs. This is a very, very, very close relationship. It's a very unique life cycle for that barnacle. Okay. One other thing we've had sitting here that I forgot to even talk about is this is a beautiful soft coral colony called a sea whip, and inside each of the tiny little polyps of this sea whip, which if they were open would be brown, are little zooxanthellae. But living in this colony are also a number of little brittle stars, and
Can you find them?
can you see them there?
Oh wait, there's one at the bottom. Let me turn it around.
Yeah, we're going to turn it around till we find
There we go.
the little brittle stars.
There's some here. The orange part. And there's some there.
Okay.
You can take it out. Oh, there's one right here.
Got it? You don't need me to hold that? Yeah, look at those little serpenty arms. And it's basically, it's just trying to hide in amongst the branches of this soft coral. Let me just see if I can get him off there.
Yeah.
And I'll put him in my hand, and that way you can see that he is indeed a little brittle star. It's kind of hard to tell when he's in amongst the soft coral. But essentially they live with that soft coral, and it gives them a safe place to hide. I think Allison and I, in a couple of minutes, are going to go try and show you our remora, which is also known as the shark sucker, the commensal that gets on sharks and sometimes sea turtles. But before we do that, I wanted to answer any questions that might have come up.
Okay. We have a question from Brenda Hillebrand, and she asked, do hermit crabs grow their shells or move into other animals' discarded ones?
They actually move into the shell of a dead snail. They have a shell over their head and legs, like most crabs do, but the whole abdomen of the hermit crab is covered, is just soft. And so they need to hide that vulnerable abdomen that everything would try and eat. And they do it in the shell of a dead snail. So they do not make that shell.
Okay. And it seems like that's the only question we have. You want to go take a look at the remora?
Look at our remora.
Yeah, we couldn't put it in a tray because
Yeah, it's too big.
they eat a lot and they grow pretty big. A pretty hungry fish. Oh, Brenda asked another question. What do you think is the most impressive symbiotic relationship?
I really think zooxanthellae is probably the most impressive, because without the zooxanthellae, we wouldn't have zooxanthellae, but the skeleton grows so slowly that they don't make big reef formations. So those, because the coral reef is such an important habitat in ocean environments, I think that relationship is probably the most impressive to me. Good question.
And when the zooxanthellae dies, is that called like coral bleaching?
It is. When corals bleach, it's usually because they literally expel their zooxanthellae. Now, if they can reestablish zooxanthellae within a couple, 3 weeks, they usually survive that. But if they can't reestablish a colony of zooxanthellae, oftentimes the coral dies as a result.
Is there a reason why they expel it?
Yeah, we think that most often it's because of elevated water temperatures.
Mm-hmm.
So that's a real concern as global warming continues. And I know there's a lot of research right now into things that varieties of corals that tolerate the higher temperatures, ways to screen corals from the effects of that hot water, but that seems to be one of the major factors. Now, they can also do that, like they can do that in result of cold water. Like a couple of times in the Keys, they've had bleaching events because of a cold snap that got the water really cold. But usually the zooxanthellae really reestablish pretty quickly after that. But once the water warms up, it tends to stay warm for quite a while.
Okay, let's take a look at some of our remoras. Oh, there's one right here.
Here he is, and he's stuck to the side of the tank position. And he uses a modified dorsal fin. The fin on the top of the body is actually modified to lay down, and what you and I would call fin rays, you know, on a fin when the little bony parts are sticking up this direction, that might stick you in the hand. In this case, in the remoras, they lay down this way. And then they've also got lots of little serrations along the edges of those fin rays. And when they come up against a shark, those little serrations and stuff kind of mesh with the dermal denticles or scales of the shark. And so it's kind of like Velcro almost. It's like little hooks. Find little crevices, not necessarily loops, but you can see. I scared him. Sorry. And that looks like a big disc on his head, like somebody stepped on it with a stretched tennis shoe. But that's all that top fin, and it's modified so that he's got that big Velcro pad there that essentially allows him to attach himself to sharks and sea turtles. And you might wonder why I say that the shark is not bothered. And that seems to be because when you see that behavior, the shark seems to continue to behave the way he was previously before the attachment of the remora. But if you see remoras get on other fish, the other fish just go bonkers. They try and scrape it along the bottom. They'll try and swim real close to other fish, hoping it gets on the other fish. I mean, they try all kinds of things. They definitely do not like the sensation of the remora. And I've had one hit on me, and I can tell you it's the oddest, it's just the oddest sensation I've ever had. It wasn't painful, but it was definitely not pleasant.
Okay. Sophie has a question. She asks, what effect does the absence of a symbiotic relationship have on animals that usually have this type of relationship?
Well, it depends on how close that relationship is. Now, and there's a whole continuum, you know, of really, really close to not so close. But things like the zooxanthellae, there are some corals that get up to 70% of their food is produced by that symbiotic algae. So if they don't have that algae, they're going to starve to death. So that is very close, and in that case, the animal probably dies. In other relationships, like we find plenty of hermit crabs who don't have cloak anemones, and they're doing just fine. Okay, it may still be an advantage to have the anemone, but it's not life-threatening if the hermit crab doesn't have one.
Okay. And in the case of parasitic relationships, obviously, you'll be happier.
Much happier. Much happier, much healthier, usually, without that parasite. But once again, oftentimes the parasite is not so harmful that the fish can't live through it. It may be, you know, it's kind of like, it is kind of like mosquitoes are essentially a human parasite. They come and suck our blood, and we don't like it, and it leaves a big bump, but we live through it, which ensures that mosquitoes keep going.
Okay. All right, I think that's it we have for questions. Is there anything else you would like to add?
There is nothing else I'd like to add, except please comment and let us know what time you would like to do the Friday live feed. That will help us in planning our future live feeds.
Yeah. If you would like it in the morning, in the afternoon, or in the evening, that would be perfect if you would leave it down in the comments.
Yeah, you don't have to be, you know, at 1:25. Morning, afternoon, evening is good.
All right, thank you for joining us. We'll see you next week.